For decades, the possibility of extraterrestrial intelligence has captivated the minds of both scientists and dreamers alike. Though our telescopes have revealed billions of stars and planets, one fundamental question persists. Are we alone? In 2022, a potential clue emerged from an unexpected place, Kepler 438b, an exoplanet located roughly 470 light-years away. This world, only 1.5 times the size of Earth and residing in the habitable zone of its host star, immediately caught the attention of astrobiologists. It offered the tantalizing possibility that liquid water and perhaps life might exist on its surface. But what truly electrified the global scientific community was an unusual radio signal. Detected by China's massive FAST telescope, 500-meter aperture spherical telescope, the signal had an incredibly narrow frequency, about 1406.04 MHz, a range rarely produced by natural sources. This anomaly sparked a frenzy of speculation. Could this be a beacon from an alien civilization? China's Ministry of Science and Technology even publicly announced the discovery, claiming that their astronomers had found potential signs of extraterrestrial technology. Social media exploded. News outlets around the world picked up the story. The possibility that we had finally received a message from the stars gripped the public imagination. And then, suddenly, the story vanished. The report was mysteriously retracted without explanation. It was as if the event had never happened. This abrupt silence only fueled more speculation. Was the signal real? Had it been censored? Or was it simply a misunderstanding? Skeptics were quick to respond. Experts in SETI, Search for Extraterrestrial Intelligence, urged caution. Among them was Dr. Ware, a renowned SETI researcher at the University of California, who insisted the signal was likely a false positive, an artifact of radio interference from Earth. This is a recurring problem in the modern search for alien life. With countless electronic devices, satellites, and communication networks surrounding our planet, distinguishing genuine cosmic signals from human-made noise has become incredibly difficult. Even famous scientists have been fooled. In 1960, Dr. Frank Drake, creator of the iconic Drake equation, believed he had detected a signal from space, only to discover it came from a stray antenna on Earth. More recently, in 2019, a team observing Proxima Centauri, the nearest star system to ours, picked up a bizarre signal called BLC-1. It was long, steady, and unlike any other out of millions they scanned. But follow-up studies revealed the signal likely came from a malfunctioning device on Earth, possibly within just a few hundred miles of the observatory. There was even a case between 2011 and 2014 where a series of mysterious signals baffled scientists until they traced the source to a microwave oven being used during lunch breaks at the observatory. These stories remind us that the search for alien intelligence is not just a scientific pursuit. It's a puzzle laden with false leads and tantalizing dead ends. It's an effort that requires caution, rigor, and a healthy dose of skepticism. The modern search for extraterrestrial life hinges on our ability to detect signals, particularly radio transmissions, from distant worlds. But in the last few decades, one uncomfortable reality has emerged. Most unusual signals turn out to be false alarms. We've seen it happen repeatedly. Promising blips turn out to be microwave ovens. Curious frequencies, often local interference. As our planet becomes increasingly saturated with human-made signals from phones, satellites, and radio towers, it becomes harder and harder to pick out what might be genuine contact from the stars. The problem isn't just scientific, it's environmental. Earth's growing radio pollution is cluttering the silence of space, contaminating our instruments, and confusing our observations. It's like trying to hear a whisper in the middle of a crowded concert. This challenge has led some scientists to suggest a bold new approach: building a radio telescope on the far side of the moon. Shielded from Earth's electromagnetic noise by thousands of miles of rock, it could offer the clearest listening post in the solar system, a sanctuary of silence, perfect for scanning the stars. But even with better tools, we're still left with a haunting question. If intelligent life exists, why haven't we found it yet? This is the essence of the Fermi paradox, named after the physicist Enrico Fermi, who, during a casual lunch with colleagues, famously asked, "So, where is everybody?" It's a question that strikes at the heart of cosmic logic. With over 200 billion stars in our galaxy alone, and likely trillions of planets, many of them older than Earth, it seems statistically improbable that we are alone, and yet the silence remains. One explanation may lie in our limited search. We've only scanned a tiny fraction of stars, barely scratching the surface. In that sense, not hearing anything yet is unsurprising. Another possibility is that we're listening the wrong way. While we search for radio signals, an advanced civilization might use completely different methods: lasers, neutrinos, quantum entanglement, or even forms of communication we haven't discovered yet. History shows that our assumptions about cosmic communication can be naive. 200 years ago, scientists proposed building giant mirrors to reflect sunlight to Mars, or creating huge triangles of fire to prove Earth's intelligence. Today we chuckle at these ideas, but what if our current methods are just as primitive? It's also possible that alien civilizations don't want to be found, or worse, that intelligent life has a tendency to destroy itself before mastering interstellar contact, a grim but plausible scenario. Despite these sobering ideas, SETI researchers remain undeterred. They believe that with enough time, patience, and technological progress, the breakthrough will come, and it must come soon. Some scientists warn that the present moment is fleeting, a narrow window of opportunity between two eras. A past when our skies were clear but we lacked the tools to search, and a future where radio pollution may render the search impossible. In this delicate in-between, we search with urgency and with hope. The Fermi paradox poses a frustrating riddle. With billions of planets in our galaxy alone, why have we found no evidence of intelligent life? One answer may be simple: we're not looking in the right way. For most of the past century, our search for extraterrestrial intelligence, or SETI, has focused heavily on radio signals. The idea is that intelligent civilizations like ours might leak or transmit structured radio waves that we could intercept. But what if advanced civilizations have long since abandoned radio technology? What if they're using something beyond our comprehension? Signals encoded in neutrinos, gravitational waves, or forms of quantum entanglement that we can't yet decode. It's worth remembering that even in human history, our concepts of communication have evolved rapidly. In just over a century, we moved from Morse code to fiber optics and global satellite networks. So imagine what a civilization a million years ahead of us might use to communicate. Looking back, the earliest SETI ideas may seem almost laughable now. In the 1800s, scientists proposed lighting massive bonfires in geometrical patterns to signal life to Martians. Others considered building giant mirrors to flash sunlight across the void. There were even suggestions to carve massive triangles into the Sahara Desert to display our knowledge of the Pythagorean theorem. Today we shake our heads at those quaint ideas, but what if 200 years from now, people look back at our radio-based SETI efforts and say, how could they have been so blind? Some scientists argue we may be limited by our own biases. We expect other civilizations to behave like us, to use our technologies, think in familiar patterns, or even have the same curiosity to reach out. But what if they don't? What if they're listening, not speaking? Or what if they simply don't care to communicate? There's also the chilling possibility that technological civilizations don't last long, that self-destruction or natural disaster ends most of them before they can make contact. This would mean the universe may be teeming with life, but silent due to brief windows of visibility. Still, not all is lost. Advances in modern astronomy have allowed us to survey the sky with greater precision than ever before. With each new telescope, we peer deeper into the galactic dark, scanning millions of stars for the faintest hint of something artificial. Projects like Breakthrough Listen, backed by hundreds of millions of dollars, are using massive radio arrays and supercomputers to filter through petabytes of data, searching for anomalies. Others are using optical telescopes to search for ultra-fast laser pulses that could indicate alien technology. There's even the wild but increasingly discussed idea of building artificial intelligence to aid in the search, programs smart enough to identify unusual signals that human observers might miss entirely. SETI, at its core, is a lesson in humility. The cosmos is vast and old. We are young and small, but that very disparity should motivate us not to despair, but to persist.